Everybody, it's Professor Mitchell. We're continuing with Chapter 11, and today we're talking about solving equations by using quadratic methods. In this section, we'll solve various equations that are quadratic in form, and then we'll solve problems that lead to quadratic equations. And we're working on SLOD, which is solve linear and nonlinear equations and inequalities, including radical, exponential, and logarithmic functions. So this is one of those sections where I think really the best way to explain it is just to show you some examples. So let's go over to the tablet. All right, starting with, we are solving the equation 9x to the fourth plus 5x squared minus 4 equals 0. So I'm about to explain to you what makes this equation quadratic in form. What does that mean? Well, notice that it is possible to rewrite this equation in the form 9 blank squared plus 5 blank minus 4 equals 0. So now I just have to figure out what to fill in the blank. I can fill in the blank with an x squared. See how that works? All right, now this next step is optional, but a lot of people find it really helpful. What I'm going to do is substitute another variable in place of x squared. And traditionally, the variable that we use for this is u. You can use any variable you want. Okay, so when you replace x squared with u, here's what you get. You get 9u squared plus 5u minus 4 equals 0. So what quadratic in form means is that the original equation is not quadratic. Remember, quadratic means a polynomial equation of degree 2. This is a degree 4 polynomial equation, which is not quadratic. However, when we fill in this other variable u, the equation becomes quadratic in the variable u. So we have now talked about 3 different ways to solve quadratic equations. You can use factoring, if factoring works. You can use completing the square, or you can use the quadratic formula. So I believe it is possible to solve this equation by factoring. Let's see. So I'm going to use trial and error because that's what I'm used to. Let's try, let's try maybe 9u and u. Okay, so we need that middle term to come out to be 5u. 4, oh, there we go, 4 and 1. There's 4u, there's 9u, and I can make that come out to plus 5u as long as I make this a plus and I make this a minus. Okay. Everybody's a factoring expert still, right? So I don't spend a lot of time explaining the factoring anymore. If 9u plus 4 times u minus 1 is 0, that must mean that 9u plus 4 is 0, or u minus 1 is 0. All right, if 9u plus 4 equals 0, that must mean that u is negative 4/9, right? And if u minus 1 is 0, that means u equals 1. So the solutions are negative 4/9 and 1. Well, not quite, because, and here's a joke that I'm very proud of that I came up with a few years ago. But this isn't about u. It's about x, right? So remember what u had to do with x. U was x squared. So if the solutions in u are negative 4/9 and 1, that means we now have to back substitute. That means x squared is negative 4/9, or x squared is 1. And now we can solve each of those equations using the square root property. Let's start with x squared equals 1. If x squared is 1, that means that x has to be either the positive or negative square root of 1, right, which is 1. So x equals plus or minus 1. If x squared is negative 4/9, that means x has to be the positive or negative square root of negative 4/9. Now remember, so you might see non-real numbers coming up here, right? I hope you do. The question in this problem was just to solve the equation. So there's no reason why this equation couldn't have some non-real solutions. It didn't come from a word problem. Okay, and in fact, this equation does have 2 non-real solutions, plus or minus 2/3 I. So there are a total of 4 solutions of this equation: 2/3 I, negative 2/3 I, 1, and negative 1. See, that's not too bad. All right, next example. It's pretty similar. So, if you're feeling frisky, go ahead and pause the video, try this one, and then come back and compare notes. All right, so 3x to the 2/3 plus 11x to the 1/3 equals 4. So first step is I'm going to rewrite this as, well, no, I guess we could do this now. 3 blank squared plus 11 blank equals 4. This blank we can fill in with x to the 1/3, right? All right, so then I will make my substitution, let u equal x to the 1/3. So now I have the equation 3u squared plus 11u equals 4, which is definitely a quadratic equation. So I'm going to put it in standard form by subtracting 4 from both sides. And I'm pretty sure that this is another one that we can solve by factoring. How about 3u and u? 4 here, 1 here, plus here, minus here, right? Okay, so that gives us that either 3u minus 1 is 0 or u plus 4, right? Yeah, u plus 4 is 0. If 3u minus 1 is 0, that means u is 1/3. And if u plus 4 is 0, that means u is negative 4. But this isn't about u. This is about x. And what was x? I mean, what was u in terms of x? U was x to the 1/3. Oops. Okay, now I can't remember if we've ever exactly solved an equation like this before. We kind of have. Remember, x to the 1/3, excuse me, means the same thing as the cube root of x. And how do you solve a radical equation? How do you eliminate the radical? By applying the appropriate power, remember? So to get rid of a 1/3 power, which is the same thing as a cube root, we are going to take the third power of both sides. And we'll do that to both equations. All right, so what does that give us? We have x to the 1/3 cubed equals 1/3 cubed. We have x to the 1/3 cubed equals negative 4 cubed. So x to the 1/3 cubed is x. That was the whole point. And then 1/3 cubed is 1/27. X to the 1/3 cubed is still x, and negative 4 cubed is negative 64, right? So the two solutions of this equation are 1/27 and negative 64. All right, last example in this batch. Y to the negative 2 minus 8y to the negative 1 plus 7 equals 0. All right, so first, write it in the form blank squared minus 8 blank plus 7. Okay, by the way, I hope you tried this problem first and are now coming back to compare notes. All right, if not, you should definitely try that now. So what's going to fill in this blank is y to the negative 1. All right, so my substitution will be let u equal y to the negative 1. I think this might actually turn out to be the easiest one because of the factoring that's coming up. U squared minus 8u plus 7 equals 0. That is a super easy factoring. I bet everybody remembers how to do that. That's just u minus 7, u minus 1. All right, which means that either u minus 7 is 0 or u minus 1 is 0, which means that u is 7 or u is 1. But this isn't about u. This is about x. And u was y to the negative 1. Yeah. All right. Now think for a second about what y to the negative 1 means. Do you remember? Y to the negative 1 means the reciprocal of y, right? So this is 1 over y equals 7. 1 over y equals 1. All right, so those are a couple of really simple rational equations. So now to solve those for y, I'm going to first multiply both sides by y, which in this case gives me 1 equals 7y, or y equals 1/7. And I'll do the same thing over here. Multiply both sides by y. Oh, that's nice. That just gives me y equals 1. So this equation has two solutions, 1/7 and 1. All right, so let's go back to the presentation so I can show you this one application problem, which will also give us a slightly different quadratic in form equation. All right, does this kind of problem sound familiar? A water tank can be filled with a large inlet pipe and a small inlet pipe in 3 hours. The large inlet pipe alone can fill the tank in 2 hours less time than the small inlet pipe alone. Find the time to the nearest tenth of an hour each pipe can fill the tank alone. All right, so I have gone ahead and gotten started setting this up. Okay, so the first thing I've done, Mitchell's first commandment, I have defined a variable. Remember the question was find the time it takes for both the small pipe and the large pipe to do the job alone. At least I think that was the question. We'll double check. Okay, so my first question for you is, if the time it takes the small pipe to do the job alone is called t, then what should we call the time for the large pipe to do the job alone? Well, the problem said that it takes the large pipe 2 less hours to do the job alone than it takes the small pipe. So that means the time for the large pipe to do the job alone, we should call that t minus 2. Okay. So this is an example of a shared work problem. We did these all the way back in chapter 7. And so we did them with these charts, remember? All right, so the time it takes the small pipe to do the job alone, we're calling that t. which means that the amount that gets done in 1 hour is 1 over t. The large pipe, it takes t minus 2 hours, which means the part that gets done in 1 hour is 1 over t minus 2. And they told me that if both pipes are turned on, then the job gets done in 3 hours, which means the part done by both pipes is 1/3. And the equation comes from the part done by the first thing plus the part done by the second thing equals the part done by both working together. So this is our equation. And I think I will go ahead and write that down on the next slide. 1 over t plus 1 over t minus 2 equals 1/3. All right, so how are we going to solve this equation? This is a rational equation. Again, did these back in chapter 7. You might be thinking, what's this doing in chapter 11? I had to think for a second what chapter we're on. All right, well, you're going to find out in a second what it's doing in this chapter. To solve a rational equation, you have to multiply both sides by the LCD. The LCD for this equation is 3 times t minus 2, right? I have 3 completely distinct denominators, so they all have to be included. Okay, so let's start with the right-hand side because that's nice and simple. Stick a 1 under there, the 3's cancel out, and just leave me t times t minus 2. All right, now I'm going to distribute 3t times t minus 2, and that is going to give me, I'm going to write it very small so that I can show as much work as possible. I think I'll be able to squeeze this in here. Okay, so that's times 1 over t, and this is times 1 over t minus 2. All right, so in that first term, the t's are going to cancel, t and this t. And in the second term, the t minus 2's are going to cancel. And I am going to be left with 3 times t minus 2 plus 3t. And then over on the other side, I have t times t minus 2. All right, so that does look like a quadratic equation. I see where the t squared is going to come up on the right-hand side. If I distribute this 3, I get 3t minus 6. Here's my other 3t. And then when I distribute this t, I get t squared minus 2t. So it definitely is a quadratic equation. We need to put it in standard form. First, I'm going to combine these like terms. That's going to give me 6t minus 6 equals t squared minus 2t. All right, and now I'm going to put everything on one side by subtracting 6t from both sides. Notice I'm putting everything on the right side. And then I'm going to add 6 to both sides. Goodbye, goodbye. All right, so that is going to give me t squared minus 8t plus 6 equals 0. All right, which is a quadratic equation. It is not a quadratic equation that you can solve by factoring. So you need to solve this one either by completing the square or with the quadratic formula. Let's use the quadratic formula. So a is 1, b is -8, c is 6. All right, so t equals minus b plus or minus radical b squared minus 4ac all over 2a. Hey. All right. So negative blank plus or minus the square root of blank squared minus 4 blank blank. all over 2 blank. All right, B is -8. B is still -8. A is 1. C is 6. A is 1. So that gives me 8 plus or minus. Okay, let's think about this. The square of -8 is 64. 64 minus 24 is 40. So the square root of 40 all over 2. All right. So now this is an application problem, and they asked for the answers to the nearest tenth. So this is another one where you don't have to find the exact solutions by simplifying the radical. We can just ask the calculator at this point, what is the square root of 40? And that comes out to about 6.32. Okay, so that gives me 2 solutions, or 2 possible solutions, I should say. 8 plus 6.32 divided by 2, 8 minus 6.32 divided by 2. All right, so 8 plus 6.32, and then divide by 2. To the nearest tenth comes out to 7.2. That would be hours. And then 8 minus 6.32 divided by 2. To the nearest tenth, that comes out to about 0.8 hours. All right, so 2 positive possible solutions. What has often happened before with word problems is that one of the possible solutions very clearly didn't make any sense, usually because one of them was negative. Well, in this case, there are 2 positive solutions to this equation. So could either one of them be an answer to this problem? Well, as it turns out, the answer is no. Remember, these are possible values for t, which is the time that it takes the small pipe. Okay, so the problem is not with the small pipe. The problem is actually with the large pipe. Okay. Because remember, it takes the large pipe 2 less hours than it takes the small pipe. So this solution is not going to work, because if it takes the small pipe 0.8 hours and you try to subtract 2 from that, then you're going to get a solution that's negative, and that doesn't make any sense. Okay, so the problem with this is it makes t minus 2 negative. Okay, but 7.2 is a perfectly good solution. It takes the small pipe 7.2 hours, and because that's t, and it takes the large pipe 2 less than that, which is 5.2 hours. All right, and that's going to do it. Oh, let me double check. That was their question, right? Yes. So I don't think you can see the question, but I can. It says, find the time to the nearest tenth of an hour each pipe can fill the tank alone. That is what we wanted. That's the end of that problem. And that's the end of this section. So we'll see you next time.